Integration by Parts, Part 4, Unusual Problems. In this video, I have 3 problems that are unusual or sort of atypical or perhaps complicated problems that we're going to do. Because I have 3 problems, I'm going to go through them a little more quickly, and I recommend that if you don't understand right away, just pause the video, think about it, or go back and look at the problems and my explanation again. So the first problem, we have a table of data, and I've given some information about the integral g times f prime. I'm telling you that f prime, g, and g prime are all integrable. That just allows me to do the problem. And our goal is to evaluate the integral of f times g prime. Well, this is a bit of a disguised integration by parts problem. We're used to doing this. Integral of u dv equals uv minus the integral of v du. We're simply going to change the notation and say that the integral of f times g prime equals f times g minus the integral of g times f prime. And then hopefully you can see that this problem really is an integration by parts problem. So let's go ahead and put some limits down, because our goal is to find the integral from 2 to 4 of f of x times g prime of x dx, which equals f of x times g of x. I'm going to leave a little space, we'll see why in just a bit, minus the integral from 2 to 4 of g of x times f prime of x. The reason I left space is because this piece right here is the end result of an integral. If you go back and look at the first video when I developed integration by parts, you'll see that this really came about because of an integral, which means I should put the limits as such. I already integrated. So the thing that we want, the left side, is f of x times g of x at 4, so we'll do f of 4 times g of 4, minus, plug in the lower limit, f of 2 times g of 2, minus this back integral, but I gave you the value up top, which is negative 2. So all we got to do is plug in from the table. F of 4 is negative 2, g of 4 is 4, minus f of 2 is 3, g of 2 is 2, and then plus 2 back there. So I get negative 8 minus 6 plus 2 equals negative 12. Not a difficult problem, but a disguised integration by parts problem. The next problem is a little bit more difficult, at least up front. This is integration by parts, so I will choose my u and my dv. I will choose my dv to be e to the x just because it's very easy to integrate that one. And then u has to be sine of x, which means du is cosine of x dx. So the integral of e to the x times sine of x is uv, I'll write as vu, minus the integral of v du. And then we need to do this again. So we have to do another iteration. I'm going to use u and dv again because too many letters gets confusing. I just know it's a new u and a new dv and all that, but based on this back integral. So I'll let u equal, well, I kind of gotta let it equal the same thing, so I'll let it equal cosine of x. dv will still equal e to the x dx. If I switch them around, I just basically get back where I started, so I gotta keep in the same direction. And I will find these things and then plug in. Integral of e to the x times sine of x is my original e to the x sine of x minus, and now I got to do my new uv minus my new integral of v du. I'm going to clean this up just a little bit. Integral of e to the x sine x dx is, let's see, e to the x sine x minus e to the x cosine x. Let's look at the back integral. I have 1, 2, 3 negative signs, so that will be minus the integral of e to the x sine x dx. At this point, it looks like we get stuck in a loop. We actually don't. From here, I can put the answer down. So I would like you to pause the video right after I put the answer down and see if you can figure out how I got it. And we need a plus c somewhere, so I'll put it over here. So where did that over 2 come from? Pause the video, think about it. When you're ready, come back. So this is how we do it. Notice that on the left side, we have an integral, e to the x sine dx. And I have minus that exact same integral on the right side. So what I really did, even though I didn't write it, was I added the one on the right to the one on the left, which would have given me 2 times that integral, or 2 of those integrals, equaled e to the x sine x minus e to the x cosine x plus some sort of c, just to make this line look like it does. I'll pretend I put plus 2c. One more problem. This is a disguised integration by parts. In fact, it doesn't even start that way. This really starts as a u sub. How do I know? Because, well, I've done this problem a few times. So we're going to do integration by substitution. I said u sub, but I'm really going to do a t sub. And I'm going to let t equal the square root of x. So remember, we're integration by substitution first, and we'll see that it ends up being an integration by parts. So if t is root x, then dt is 1 over 2 root x dx. And I'm going to substitute x's for t's. I get e to the t. And then I have a dx, which I have to deal with. So let's look it over here. Notice that dx is 2 root x times dt. I really can't have any x's on this side. So if I continue on and realize that t is root x, I have 2t dt, which I can now substitute in for dx. And this is an integration by parts. I could do tabular method. I'm just going to do kind of the old school way. Setting up my u and my dv, I will let u equal 2t, dv equal e to the t dt. Find my du and my v. And then I remember that the integral of u dv is uv minus the integral of v du. I will plug in. uv is 2t e to the t minus the integral of v du, so 2 e to the t dt, which gives me 2t e to the t minus the integral of 2e to the t is 2e to the t. Put plus c now. But I started the problem with x's, so let's end with x's by back substituting. I'll put root x for every t, so I get 2 root x times e to the root x minus 2e to the root x plus c, and that's our answer.